Hello everyone, and welcome back to the channel. Today is Friday, April 17, 2026. I am your host, a laid-back guy who just loves talking to himself and transcribing what other YouTubers are doing. Right, and today I am introducing a trending article from the archives. It is a fascinating read that really caught my eye. The title is Few-Shot and Pseudo-Label Guided Speech Quality Evaluation with Large Language Models. The title is Cogs and 14,528 long. It is long. Before we dive in, I have a quick joke for you. Why did the audio signal refuse to talk to the language model? Because it had a zero crossing rate of 0 and just could not find the right frequency to connect. Yeah, I know that one really fell flat, but let us move on to the good stuff. So what is the big problem that this paper is trying to solve? Measuring how good speech sounds has always been a major headache for engineers. The gold standard has always been to just asking your listeners to rate it. This is called a mean opinion score, or MOS for short. But gathering humans to sit down and listen to hundreds of audio clips is super expensive, and it takes a massive amount of time to get reliable scores. To fix this, people started building deep learning models to predict these scores automatically. The problem is that these traditional machine learning models require a huge amount of labeled data to train properly. If you do not have enough training samples, the models become completely unreliable. Recently, researchers tried throwing raw audio into large language models like ChatBot, hoping the AI could just figure it out. But as it turns out, language models struggle to understand raw audio directly. And if you only give them basic handcrafted features like the volume or pitch, they just do not have enough context to make a good guess. This paper introduces a totally new framework called GatherMOS. Instead of forcing the large language model to listen to raw audio, GatherMOS treats the AI as a kind of meta-evaluator. It takes diverse, lightweight acoustic signals and combines them with pseudo-labels from existing simple models to feed a highly structured text prompt to a model like GAT5. It basically translates the mess of audio directly to a clean logical summary. So the language model can use its massive reasoning brain to predict the speech quality. Let me explain how it works in more detail, because the approach is actually quite clever. First, the system extracts basic features from an audio clip. It looks at the root mean square, which tells us the overall energy or volume of the signal. It checks the signal crossing rate, which helps identify how noisy or voiced the speech is. It also checks if the audio is clipping, which happens when the volume is too loud and distorts the sound. To get even more detailed, it pulls out mel frequency and upstroke coefficients, which are basically a mathematical representation of the texture of the sound, along with spectrogram images that show the frequency distribution. Here's where it gets really interesting. GatherMOS also brings in two lightweight, specifically DensMOS and VASCOR. These are smaller, efficient algorithms that give a quick, rough estimate of the speech quality. GatherMOS takes these rough estimates, which the researchers call pseudo-labels, and hands them over to the large language model along with all those acoustic features. The language model then acts like a wise judge, weighing the rough estimates against the hard acoustic facts, and outputs a final, highly accurate, mean opinion score. The researchers tested two different setups for this, which are zero-shot learning and few-shot learning. In the zero-shot setup, the model is just given the data and told to make a prediction about any prior examples. This proved to be incredibly robust, maintaining stable performance across all sorts of different audio environments. In the few-shot setup, the model is given a few examples of audience scores inside the text prompt, just to help calibrate its expectations. The paper found that if the examples perfectly match the type of audio being tested, the few-shot method gives a massive boost in accuracy. That if the examples are from a different audio environment, it can actually confuse the model and lower the accuracy. And they compared GatherMOS against other technologies. The results were extremely impressive. They tested it on the void-band demand dataset, which includes clean speech, noisy speech with car or cafe background sounds, and speech that has been processed by various enhancement algorithms. GatherMOS consistently outperformed the Stunno and DensMOS and Vomble models. They also beat naive ensemble methods, where you just average the scores of different models together. More importantly, we completely crushed traditional learning-based neural networks like Seed and Bonespoon and Moss, when those networks were restricted to very limited trained data. So, how does this actually impact our everyday lives? I have 3 specific application examples where this technology could be a game changer in the real world. First, let us think about everyday telecommunications. Like when you're on a video call using platforms like Zoom or Microsoft Teams. Right now, if your network connection drops or background noise increases, the software tries to suppress the noise, but it often makes your voice sound robotic or muffled. By integrating GatherMOS into the communication pipeline, the software could continuously evaluate the quality of your speech in real time, using extremely lightweight features without needing human labels. If the language model detects that the voice quality is dropping below an acceptable threshold, it can automatically tell the system to switch to a different noise suppression algorithm, ensuring that you always sound natural and cool to the people on the other end of the call. Second, this technology has huge potential for the hearing industry. Modern hearing aids use complex algorithms to amplify human speech while tuning out background noise. However, tuning these algorithms usually requires the patient to sit in a clinic, giving feedback to an educologist over multiple sessions. With GatherMOS, hearing aid manufacturers could build automated, non-intrusive evaluation system. The hearing aid could record short snippets of the user's acoustic environment, extract the basic features like the zero crossing rate and clipping ratio, and use a cloud-based language model to evaluate the speech quality on the fly. This means the hearing aid could automatically adjust its own parameters down the line, providing the user with the best possible listening experience without needing constant manual adjustments. Third, let us talk about the booming field of generative AI and text-to-speech systems. Nowadays, companies are creating synthetic voices for audiobooks, virtual assistants, and video game characters. But testing whether these AI-generated voices sound realistic is incredibly tedious, because developers have to hire hundreds of people to listen and rate the audio. GatherMOS could completely automate the quality assurance process for synthetic media. A company generating thousands of hours of synthetic speech could just run the audio through the GatherMOS framework. The system would combine the low frequency, the straw coefficients with the pseudo labels, and the large language model would spit out a highly accurate, human-like reading for every single file. This would drastically speed up the development of new synthetic voices, saving companies millions of dollars in testing costs, while ensuring that the final product sounds indistinguishable from a real human being. What I really love about this paper is how it highlights the changing role of language models. We are moving past the point when we just use AI to write emails or answer trivia questions. Now, we are using the logical reasoning capabilities of language models to act as a central brain when it interprets complex, multimodal sensor data by translating audio properties into text-based context. You can bypass the need for massive, perfectly labeled audio datasets. It is a brilliant workaround that makes speech quality evaluation far more accessible and scalable. That is all for today's deep dive into the archives. I hope you found this breakdown as fascinating as I did. It really shows how fast audio processing and AI are evolving together. Thank you so much for hanging out with me today, and I will see you in the next transcription session.